Hi, in this presentation, I'm going to show the position of orbital ellipse of a satellite in space in relation to the Earth's coordinate system. I will show how this orbit should change and rotate so that it can be transformed to the Earth's coordinate system. This is the subject that the students normally have problem to digest, and I think that by using this animation, I can help them to understand the concept. Now I explain the Earth coordinate system. Earth coordinate system has its center at the center of the Earth, and its x-axis is moving towards the north of the north, or the Earth's rotation axis, and the x-axis is towards the vernal equinox, which is a constant point in the space, and the system is completes a right-hand system. It means that if you have your thumb along the z-axis and your fingers along the x-axis, with a simple rotation, 90-degree rotation, you can find what it means the y-axis. And here the goal is to show the position of satellites with respect to this Earth coordinate system. Now I define the orbital coordinate system. Consider the orbital ellipse. The farthest point from the Earth is called apogee, and the closest one is perigee. The line passing through these two points is called line of apsides. And y-axis is defined perpendicular to this line of apsides, and the z-axis is perpendicular to the orbital ellipse, or both of these axes. So if you put your thumb along the z-axis and your fingers towards x with a simple rotation, the counterclockwise rotation, you can find the direction of y-axis. This means that the system is right-handed. Here I'm going to show how the orbital ellipse can rotate around the z-axis. We have rotation around y-axis as well, and rotation around z-axis. So the question is how to transform these coordinates only by these three rotations to the Earth's coordinate system. Now I put the center of the orbital coordinate system at the center of the Earth and expand the Earth's equator to get equatorial plane. Thereafter, I rotate the orbital plane around its z-axis, and I get right ascension of ascending node, which is the angle between the x-axis of the Earth coordinate system and x-axis of the orbital coordinate system. Ascending node refers to a point from which the satellite goes above the equatorial plane. Now if I rotate rotate the orbital plane again around the x-axis, I get inclination. Inclination is the angle between orbital plane and the equatorial plane, and the intersection between these two planes is called nodal line. Now I rotate again the orbital plane or orbital coordinate system around the z-axis of the system to get perigee argument. Perigee argument is the angle between the nodal line and x-axis of the orbital coordinate system, which is the same with line of apsides. I hope by this animation and explanation I could help you to understand the concept of orientation of the orbit in the space. I have designed 5 questions, and you can test yourself if you have understood the concept well or not.